In many videos, we have already talked about metals and metallic bonds. And in this video, we're going to dig a little bit deeper. And in particular, we're going to talk about alloys, which are mixtures of elements, but still have metallic properties. So first of all, what are metallic properties? Well, those tend to be things like they're shiny, they reflect light. This is actually a pure iron sample right over here. You can see that it reflects light. It tends to be malleable, which means you can bend it without breaking it. And it tends to conduct electricity. And alloys are when you can mix multiple elements together and still have most of these properties. And just as a review of where these properties come from, we can imagine metallic bonds. And there's a whole video on this. But in metallic bonds, let's say we were to take a bunch of iron. And you can see right over here, iron, Fe. It is a transition metal. And what happens with metals is when they form bonds with each other, their valence electrons, because each of the atoms aren't that electronegative, they don't want to hog the electrons. They don't want them just for themselves. They're willing to share their valence electrons into a bit of a communal pool of electrons. And so even though you have a bunch of neutral, let's say, iron atoms, you could actually view them as positively charged ions in a sea of electrons. And so you have a bunch of electrons here. And where do these electrons come from? Well, these are the valence electrons from the neutral atoms that get contributed to the sea. And this is why most metals are good at conducting electricity. This is why they are malleable. And depending on the metal, if you're talking about a group 1 metal, you can imagine that the charge of these ions right over here would be a +1. But if you talk about a group 2 metal or a transition metal, they have more valence electrons that they might be able to contribute to this pool. And so if you're thinking about these ions, they could even have a +2 charge or a +3 charge. But as promised, in this video, we're going to talk about the notion of alloys. And we're going to do these particulate diagrams that we have seen in other videos. And in the particulate diagrams, we're not going to show this sea of electrons, but they're going to help us visualize the structure of the alloys. So let's imagine what iron could look like. And we're just going to look at a two-dimensional slice of a solid of iron where all of the iron atoms have formed metallic bonds. And as I said, we're not going to draw this sea of electrons, but they might form a pretty regular structure, something like this. And so each of these circles represent an iron atom. But as promised, this video is about alloys. So let's imagine what steel might look like. This is a steel blade. And steel is a bunch of iron, so once again, we can visualize each of these as an iron atom. But mixed in with that iron is a little bit of carbon. And when you look at the periodic table of elements, you can see that carbon is a good bit higher on the periodic table of elements and to the right of iron. Neutral iron has 26 protons and 26 electrons. Neutral carbon only has 6 protons and 6 electrons. The valence electrons in carbon are in their second shell. The valence electrons of iron are in the fourth shell. So carbon is a good bit smaller. And so when you mix that carbon in, because it is smaller, it's able to fit in the gaps between the irons. So you might have, actually I'll just write it here, you might have a little bit of carbon there. You might have a little bit of carbon there. You might have a little bit of carbon there. And so when you form an alloy where one atom has a larger radius or significantly larger radius than the other, you tend to form things like this, which are known as interstitial alloys. And basic carbon steel is a good example of it. Now you have other situations where you have alloys between atoms of similar size. And this right over here, this is a brass, I don't know what this is, a clock or an astrolabe or something like this. But brass is made up of a mix of copper and zinc. And so when you have an alloy like this that's between atoms of similar radius, this is called a substitutional alloy. You can imagine that some of the copper has been substituted with zinc. So this is substitutional alloy. Now, the last thing you might be wondering about is, can you have a combination of both? And you indeed can. This over here are panels on the International Space Station, and it's made out of stainless steel. You're likely to have stainless steel in your kitchen. And stainless steel you could view it as it's basic steel, but instead of just iron and carbon, it also has a little bit of chromium mixed in. And so we can visualize this. If this is stainless steel, maybe the blue ones we say are iron, but it has a little bit of chromium. I'll do that with red. Chromium has a similar radius to iron. It's not exactly the same, but it is close. So maybe a little chromium there, a little bit of chromium right over there, a little bit of chromium right over there. And if it was just iron and chromium, we would call it substitutional, but it also has carbon, and carbon has a smaller radius. So maybe a little bit of carbon fitting in the gaps between the larger atoms there, a little bit of carbon there, a little bit of carbon right over here. And so this is an example of an alloy that is both interstitial and substitutional. Now, one final question, you're like, okay, this is all interesting, but why have we decided to put things like carbon in iron? Well, it turns out that even by putting a little bit of carbon in or mixing in with other metals, you're able to change the properties. And for example, steel as an alloy is much stronger than iron by itself. And stainless steel, once you mix that chromium in, it's much more resistant to corrosion than basic steel. So I'll leave you there. You just learned a little bit more about metals and alloys.